This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 5, Lesson 8, Cooling and Heating Coils. The coil as equipment. In Week 1, you saw the cooling coil as a process on the psychrometric chart. Now we treat it as hardware, a heat exchanger with air on one side and a working fluid on the other. We split the load into sensible and latent, then size the water side with UA and LMTD. The idea. Week 1 described the coil as a process, a line on the chart with apparatus, dew point, and bypass factor, answering what happens to the air. This lesson is the other half, the coil as hardware. It is a heat exchanger, air one side, a working fluid the other, so it obeys both descriptions at once. The air side sets the duty, the water side gets sized like any exchanger. The air side has two modes, a sensible-only coil, a heater, or a cooling coil above the dew point, holds the humidity ratio, so the whole enthalpy change is sensible. A cooling and dehumidifying coil runs below the dew point. Moisture condenses, and the load picks up a latent part, with a small condensate enthalpy correction. Either way, the total is sensible plus latent. A hot water or steam coil is just the sensible case with the fluid as the hot stream. Bypass factor and apparatus dew point are design concepts, not in the handbook. The relations that size a coil. The air side gives the total duty, sensible plus latent. A water side energy balance turns that duty into a flow rate. And the exchanger rate, UA times the log mean temperature difference, turns it into a size. The coil load and the exchanger rate are the same quantity, so set them equal and solve for UA. The givens. 20,000 pounds an hour of dry air, entering at 80 degrees and 0.0140, leaving at 54 and 0.0085. Enthalpies come from the printed moist air relation, 34.5 in, 22.2 out. On the water side, chilled water enters at 44 and leaves at 56. Solve the air side. The total, from the cooling and dehumidification form, is about 245,000. For the sensible part, hold the humidity ratio and cool to the leaving temperature. That intermediate enthalpy gives a sensible load of 128,000. Latent is the remainder, about 117,000. The coil drips 110 pounds an hour, and the mass times latent heat check confirms the latent number. The equipment. Air enters at 80 and leaves at 54, dropping moisture as condensate. Chilled water runs the other way, in at 44, out at 56, so the coil is a counterflow exchanger. The temperature gap is 24 degrees at the air in end and 10 at the air out end, and those two ends set the log mean difference. Solve the water side. A water side energy balance turns the total load into a mass flow, and dividing by density and time gives about 41 gallons per minute. Note there is no magic 500 factor. It comes straight from mass times specific heat times delta T. The two end temperature differences give a log mean of 16 degrees, and UA is the load over the LMTD, about 15,300. One caution. On a wet coil, the real driving force is enthalpy, so that UA is a first cut size. The traps. 1. Don't drop the latent load. Sensible here is only about half the duty. 2. Remember the coil is a heat exchanger. The load sets the duty, but you still size the hardware with UA and an energy balance. 3. A temperature-based LMTD on a wet coil is only a first cut. 4. Bypass factor and apparatus dew point are not handbook formulas. 5. A real coil is cross-flow, so the correction factor is below 1. F equals 1 only for pure counter or parallel flow. Quick recall. A coil is both a psychrometric process and a heat exchanger, so size both sides. Sensible only is the dry air enthalpy change. Cooling and dehumidifying adds a latent part and condensate. Split the total into sensible plus latent. Get the water flow from an energy balance, and size the coil with UA and the log mean temperature difference. Bypass factor and apparatus dew point are concepts, not handbook formulas. Golden rule. Never drop the latent load. Next up, Lesson 9. Pumps and compressors. the machine rather than the system. We take the affinity laws for speed and diameter, NPSH and cavitation as the suction head margin, and compressor work. Everything is at peprepengine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.